Hi, in this video let's see some basic concepts of probability. In general, probability of an event is equal to favorable divided by total number of cases. For example, what is the probability of getting a head? If I toss a single coin, we have either head or tail. So 1 by 2, because total we have two options, head or tail, and out of that I want probability of getting a head. So 1 by 2. For example, I am throwing a dice. What is the probability of getting a number 1? When we throw a dice, how many values we have? 1, 2, 3, 4, 5, 6. Right? So total we have 6. Out of that, I want probability of getting the number 1. It's 1 by 6. Similarly, probability of getting the number 2. There is only one value, right? So 1 by 6. What is the probability of getting number 4? It is where there is only one 4. So 4 by 6. So this is how we will write a probability of an event. Always remember that your probability values lies between 0 and 1. Because for sure event, probability of a sure event is always 1. Probability of an impossible event is always 0. For example, what is the probability of getting a gold rain today? So I will write 0 because it's an impossible event. So probability of a sure event means what is the probability that I'm breathing right now? So we are breathing, right? So for sure this is happening. So we'll write 1. Always the probability value lies between 0 and 1. And mutually exclusive and exhaustive. So what do you mean by sample space means? A sample space has finite number of elements. Okay. So if an event contains all possible outcomes, then I will call it as a mutually exhaustive event. So it should contain all possible outcomes. Same way, mutually exclusive means we say two or more events mutually exclusive if happening of one event prevent the happening of another event. For example, I am tossing a coin. If a head comes out, it prevents the happening of tail. So we call it as a mutually exclusive event. It's like happening of one prevents the happening of another. But in the case of independent event, if one event does not prevent the another event, then we call it as an independent event. For example, same, I'm tossing two coins. Getting a head or tail in the first coin is not going to affect a head or tail in the second coin. So this we call it as an independent event if I'm tossing two coins. Whereas mutually exclusive means I'm tossing one coin. If I get a head, it prevents tail. So this is the difference between mutually exclusive and independent event. Again I repeat, independent event means one event does not prevent the another. For example, if I get head or tail in the first coin, if I toss two coins, it's not going to affect the second one. And these are the axioms of probability. The first one is probability of a sure event is 1. And for every event, the probability lies between 0 and 1. And finally, mutually exclusive event means P of the last one, P of A1 union A2, etc. union A1 is equal to P of A1 plus P of A2 plus and so on, P of AN. I can write like this if the events are mutually exclusive. Just now we saw what do you mean by mutually exclusive event. And coming to the addition rule of probability. So P of A union B is equal to P of A plus P of B minus P of A intersection B. This is the addition rule. We are going to prove it by using Venn diagram. So now see the diagram. This is A and this is B, and see here, A is a combination of A intersection B and A bar. Sorry, I will write like this. A is a combination of A intersection B is in the middle. And the other one is A intersection B bar. It's like A doesn't have any part of B. So this is B bar. So A is a combination of A intersection B and A intersection B bar. So I have written A is equal to A intersection B bar union A intersection B. So by the third axiom, what I can write? P of A is equal to P of A intersection B bar plus P of A intersection B. Similarly, B is a combination of A bar intersection B and A intersection B. Correct? This is what I have written. So P of B is equal to P of A bar intersection B plus P of A intersection B. And finally we are writing A union B. And A union B is a combination of A intersection B bar, A intersection B and A bar intersection B. All the three. So I can write this as P of A union B as P of A intersection B bar plus P of A intersection B plus P of A bar intersection B. Now we are almost done. And you can see P of A, P of B here. When I add P of A and P of B, I'll write this, I'll write this, this and this. All these four I have written. Okay. And now when you have this equation 3 right hand side, what are the three things you have? A intersection B bar. Yes, we have. A intersection B. Yes, we have. A bar intersection B. Yes, we have. So these three things together, I can write it as P of A union B. Then if I push this A intersection B to the other side, I can prove this axiom that P of A union B is equal to P of A plus P of B minus P of A intersection B. Hence, we have proved the addition theorem by using Venn diagram. And now coming to the definition of conditional probability. Let A and B are two events. Probability of happening of event B when the event A already has happened is called conditional probability. For example, I have a pack of 52 cards. If I say what is the probability of getting a king? We have king in 4 colors, right? 4 out of 52. I'll write like this. So now I have taken one card already and I'm taking the second card now. So in that case, first event already happened. I don't know what card it is. Now total is 51. Already I have taken one card. I'm continuing it without replacing it. So in that case, conditional probability will come into the scene. So it means I'm finding the probability of getting a king now when already I have selected one card. Okay. So, and see the formula for this conditional probability. P of B given A means P of A intersection B divided by P of A. Similarly, A given B. It means what is the probability of getting A if the event B has already happened. That's equal to P of A intersection B by P of B. So this is the formula for conditional probability. And by using multiplication rule, if you see here, P of B given A is P of A intersection B by P of A. So I can write P of A intersection B is equal to P of A into P of B given A. Similarly, I can write P of A intersection B is equal to P of B into P of A given B. I can write this way also. This we call it as a multiplication rule. And remember, we studied about independent events. If A and B are independent events, happening of one is not going to disturb the happening of other. So in case of independent event, P of, say for example, I am taking this first one. So P of B given A is going to be same as P of B if A and B are independent event. Because this is not going to affect the other one. So automatically this is purely based on P of B. Whatever happens in A is not going to affect. So in that case, P of A intersection B, I can write it as already we have, for example, I am solving it by equation 1. P of A is already there. P of B given A, I can write it as P of B. So I can write a P of A intersection B as P of A into P of B if A and B are independent. We have seen all the basic definitions. Now let's solve some problems. So 2 dice are rolled. What is the probability of getting sum as 4 in both the dice? So if I am rolling 2 dice, what are the possibilities? 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. This is one combination that in the first dice it's always 1. And in the second dice I'm getting 2, 1, 2, 3, 4, 5, 6. Similarly, first dice is always 2. Second I'm getting 1. Like this I'll be having 6 combinations. Similarly 3, 1 up to 3, 6. Similarly 4, 1 up to 4, 6 and 5, 1 up to 5, 6. It's like we are writing all the possibilities because the denominator is total number of cases by favorable. So, sorry, favorable divided by total number of cases. So, how many total number of cases are there? All thing if we count, it is going to be 36. So, your denominator is 36 in this case. So, the probability of getting the sum as 4 is, denominator I have written 36. Now, out of these combinations, which combinations will give the sum as 4? Let us write, say 2, 2. And then, what else? 1, 3. Right here also the sum is 4. And then, what else? 3, 1. 1, 2, 3. So, 3 cases are favorable out of 36 cases. So, this is the probability of getting the sum as 4. For example, if I change the question as, what is the probability of getting the number 2 in both the dice? So, we have total 36 and 2 and 2 will come only in one case. So, it is 1 by 36. So, we have to write the denominator total number of cases and in the numerator what is favorable to this particular thing that we need. But always remember, whenever we are throwing 2 dice, the denominator need not be 36. Same question, 2 dice are rolled. If the sum obtained is 4. Okay, now I am changing the question that after rolling it, I am getting the sum as 4. What is the probability that the number obtained in both the dice are even? So, even numbers are 2, 4 and everything, right? I already said the sum obtained is 4. So, what are the possibilities? 2, 2, 1, 3, 3, 1. So, these are the total possibilities. In this, which combination has both even numbers? 2 and 2. Only this combination. So, here probability of or the required event is equal to 1 out of 3. Because if the sum obtained is 4, even though 2 dice are rolled, I am getting 36 outcomes. But here, I am reducing it to this narrow case that if the sum obtained is 4. So, find the probability that number obtained in both the dice are even. So, we have now sum obtained 4 means only 3 options. Out of this, 2 numbers even means I will get only one option. So, I will write 1 by 3. So, you have to be very careful when you are writing favorable by total number of cases. Let us see this question. The probability that 3 students A, B, C solve a problem is 1 by 2, 1 by 3 and 1 by 4 respectively. If the problem is simultaneously assigned to all of them, so we are giving at a time to all of them, what is the probability that the problem is solved? Okay, so A solving a problem 1 by 2 I have written from the question. B solving a problem, probability is 1 by 3. C solving a problem is 1 by 4. So, I want to know the probability that the problem is solved by any one of them. So, what is the opposite? We always know total probability is 1. 1 minus probability that no one solves will give you the answer. Okay. So, from the total probability 1, if I subtract no one solves, it will give you the probability that is required. So, P of A is 1 by 2 means P of A will not, what is the probability that A will not solve the problem is A bar. So, that is 1 minus 1 by 2, that is again 1 by 2. Similarly, P of B bar is 1 minus 1 by 3, that is nothing but 2 by 3. Similarly, C bar is 1 minus 1 by 4, that is equal to 3 by 4. So, 1 minus probability of no one solves the problem. Since these are all independent events, right? Whether A is solving or not is not going to affect B. B solving or not is not going to affect C. So, if A, B, C are independent, then A bar, B bar and C bar also independent of each other, provided they are not copying. So, 1 minus 1 by 2 into 2 by 3 into 3 by 4. Because these events are independent, we can write like this, and this is nothing but 1 minus 1 by 4, that's equal to 3 by 4 is the solution. So, let's solve more problems in the next video. Thank you.